Hello, I'm Anthony from Campbell Associates, and today I'm going to tell you about CadnaR, some noise modeling software for room acoustics. My colleague John is also going to join me today in this video to show you how to model rooms, but I'm going to show you how you can intuitively do this seamlessly from your iPhone and get that model into the software in just a few minutes without you having to spend hours modeling the room. But let's start with the CadnaR app. It's very simple. You load in this app, you can tap on the bottom, and you get this camera display of the room. And what happens is, it will start scanning this room to measure the dimensions of the wall, of the door, the frame, the roof, into the corners. And at the bottom, we start to get a 3D model of our room without me doing any modeling in any post-processing software on my computer. And as you can see, it's really cool. It starts drawing these lines, the desk, the chairs, and our acoustic barriers if we need. So now you completed your measurement, you can simply open this model within your iPhone. You can delete objects, you can amend the elements, and this allows you to visualize the whole room and simply export this by pressing a button on the bottom of the screen, going to export or share and emailing the file to yourself, and then you can import this into CadnaR. And it's brilliant because you can choose whether you would like the furniture, the elements, or the objects of the room imported into CadnaR. So it's a very simple file, import, find the measurement, import the model, and visualize what you have done.
Hello, my name is John Campbell from Campbell Associates. This is just a short introductory video to give you a taste of CadnaR, the software package from Data Acoustic for the prediction of sound inside rooms. Also within the suite of software from Data Acoustic, we have CadnaA, which is widely used for environmental noise prediction. And we have CadnaB, which is a building acoustics planning system, which is for sound insulation prediction and how sound transmits within a building and between rooms. Now we're going to have an introduction to CadnaR, prediction of sound inside rooms. So if I open up the software, the purpose just to give you a bit of a flavour how it looks and how it works. We have a standard workspace here on the screen. We have menu convention along the top, a toolbar, and we have a toolbox to manually enter objects onto this workspace. We have scaling at the bottom, X and Y, always in meters. So we can manually enter this information into the file, or we can import. So if we want to have a look at the import options, we've got File, Import, and you can see the files of type at the bottom here. We can import from other CadnaR files. We can import from AutoCAD, DWG, and DXF. We can import from SketchUp and from ASCII files. So for now, we're going to have a look at a SketchUp file, and we have here an office being modeled in SketchUp, and we're going to open that into CadnaR. Okay, so you can see it's imported some objects here. If I click on them, you can see that we've got some objects which have been imported into the software very efficiently. If you want to have a look in the 3D view, you can just click on the 3D box there, and you can see these objects. And we can rotate here. You can click on them the same in the 3D view to get to the information on this box as this information here, this barrier also. So you can do it from the 3D or from the 2D view. So we've got something here. We can do a quick calculation. So if I take a point source, I'll place that in a seated position, this desk here. Click on the point source and we get to the edit box. So everything has an edit box, so just call that speaker, somebody talking. So in the seated position with the Z coordinates, we'll just put in at perhaps 1 meter. For the spectrum, we will just type that in here, or we can click to our global library and we can select. So we've got one here with normal speech. So fine, okay that. And click that through, we now have an object. Then if I want to put a receiver on, I take the receiver icon, drop that down onto this desk here, double click, and we get an edit box for the receiver. So I'll just call that receiver 1. We've got the same coordinate options here. So if I put that in at 1 meter as well, so in a seated position. And you can see here we've got a box waiting for it to be populated once we've done the calculations. So let's do that. So click OK. We have a few calculation options. We've got here individual receiver calculations with a calculator, and we have some grid calculations with these two here. So for now, let's just do a quick calculation. It's done that. Come back to the receiver. You can now see that it's actually populated it. So we have the sound pressure in each of the octave bands. We have the reverberation time, T10, 20 and 30, early decay time, some clarity indexes here. We also have in this right-hand panel some noise reduction, STI, steeper, and so on. It's all calculated very quickly. We can see the reverberation time graphically. We can see the octave bands there. We can see the echogram, so you can see the decay against time in each of the frequencies, and it's quickly calculated. So we have a file there. Perhaps we can start adding some additional information in, but before that, let's just add a label in here so we don't have to drill into the receiver to see the numbers that we're interested in. So if I right click on an object, we've got a generate label, and we can put in any of the attributes, the height, the name, any of the frequencies, but we've just asked for the label to show the sound pressure level. Okay, and if I click here, I can select a font size, so it's something reasonable. And I can rescale that just by moving it there. If I catch the corner of it, I can resize the box size. Okay, so perhaps if we want to put something in there to reduce the sound, we can increase the height of the barrier, or I could put an acoustic panel in the ceiling. So to do that, I'm just going to take the box object and just draw a box like so. And we've got a panel that I need to enter the dimensions for. So here I can enter a Z height. So if I put it at 3 meters, which is ceiling height, the Z height is the bottom height of that object. So if I put that in 2.9 meters, then it's dropping down 10 centimeters from the ceiling. Another one, we can put some absorption in. So if I go to the library, you can see we've got some objects already hard programmed into the software. So we can select any of those. Perhaps if I take this one here, we've got some sound absorption data which has been transferred into this object now. Let's have a look at that in the 3D. So you can see we now have our screens here, but we also have our panel in the ceiling, and I can edit that or view it and edit it from this 3D view. Okay, so let's see what difference that makes to the calculation. So it's 60.8. If I click the calculator, you can now see we've got a benefit of 4 or 5 dB from putting that panel on the ceiling. Okay, so we can now duplicate that if we want. So if we want to, this is doing what we want. So perhaps we can just drag it. If I hold the control key down, it doesn't just move it, it actually duplicates it. So we get a duplicate objects where we need it, and you can see these are updated in the 3D. So it's a really nice tool, and everything is held in the software. You don't have to do it in Google and import it again or other packages. Once you've got it imported, you can play within the software and do some things, really neat things very easily and efficiently. Okay, and if we want to calculate again, okay, so we've got a slight benefit from reducing the overall sound reduction for the room. By reducing the reverberation in the room. So we can have a look at some of the other tools in there as well. So in the representation, we can have a look at this particle model. So you can see that we can bounce rays around the room. So you can actually see how they're reflecting and the important surfaces to cover. That's all in there. You can see we've got a nice interface there. If we want to have a look at grid maps, so I need to calculate these grids. So this is just a 2D grid, and this voxel grid is a 3D grid. So it will do it at different elevations across the whole block of the room, if you like. So if I calculate that, you can now see in the 3D view, we've got some sound levels calculated. Plus, you can see it makes these boxes bigger, so we start to fill that out. Press the X you can see it moves in this plane. If I hit the Y on my keyboard, it's in that plane, and Z moves it up and down. So we've got a color contour maps to show the dispersion of the sound levels around the room. And we can also do that for sound STI and so on, and reverberation time and individual third or octave bands, frequency bands. Okay, so that gives you an idea of how quick it is and how flexible it is to use for the modeling. So I could also show you some examples of how we might handle more complex offices. So here we can see we've got something similar with different desks across a slightly bigger office. We've put some speakers, some graphics of people sitting in there, but you can see we've got the same receiver modelled at the listener's receptor's position. Boxes here, these level boxes, we're showing the level, but we're also showing the sound STI there as well for each of these receivers. So if we want to, we can also start modelling extra barriers or some absorption panels in the ceiling. And we can also handle these in multiple groups and associate these with different variants. So we can have up to 16 variants in an individual file. So you can see here in this example, we've got acoustic ceiling, some of these extra panels. So perhaps if I show you in the 3D, I'll make that a bit smaller. So you can see these panels are activated, so no measures, the office as we have it. We can put an acoustic ceiling in, so these additional areas appear above the desks. And you can see that the levels change at all of these receivers when I switch to these different scenarios. And then we can go to some additional screens, and you can see that the desks or the workspaces are then divided up further with additional acoustic panels, and you can see how the sound levels change and the STI changes very quickly. So you can model lots of different scenarios to see which works best and weigh it up against cost and the benefit acoustically, and you've got a nice tool to present this. Okay, we can also use the software for other applications, so it's not limited to offices. So we have here an example of, let's have a look at this one here. We have a factory, so we have here a bottling plant. So here we have the bottling plant modelled. If I show you in the 3D, get a bit of flavour, so you can see we've got a line of bottles. You can see them graphically represented here, which are travelling around this conveyor belt. And the application here is to predict the sound pressure level inside the building for exposure to the people working there. Move this over. You can see we've got different scenarios here. So if I turn the bottling plant on, so now these transfer from being just objects to being emitting sources. So you can see we've got sound emission from all of these now. And you can see we've got the workers' positions marked as these receiver points, and you can see the sound pressure level here. So you can see we've got some very high sound pressure levels. You can see the noise at work regulations. And then we can start to model different scenarios. So here we've got here for baffled ceilings. So let's have a look at this in the 3D. So you can see we've got baffled ceilings hanging from the roof to increase the absorption to reduce the reverberant sound. Okay, and you can see the sound level starts to drop. So you can see these ones here dropping to 86, 88. So we're under the 90 dB, but obviously there's more work to do. But once we've got it modelled here, it's efficient and easy to do. Okay, then we'll have a look at a final example, just to give you another application this is used for. So here we've got a theatre space. So we have a auditorium. And if I show you again in the 3D view, we've got this modelled here with acoustic panels suspended from the ceiling. So we've got tiered seating with receivers on all of these, so we can actually start modelling the sound pressure level and room acoustic parameters for each of these receivers. You'll also see that we're not limited to square or rectangular buildings. So the workspace is always square or rectangular, but obviously we can model our rooms any shape we like within those confines of the rectangular workspace. Okay, and then we have a really nice tool that we can use for our acoustic work to optimize rooms. And also we have a very nice tool for presentation. Okay, so hopefully that's given you a good flavour of how it works and how it looks. It's a really nice user-friendly package. If you've used CadnaR A before, which is widely used, it's a very familiar interface. You can see it looks quite similar, so you'll be up and running very quickly with it. If you're interested, please get in touch with us at Campbell Associates or the guys at Data Acoustic, and we would be happy to talk to you, provide quotations or evaluation licenses. Okay, thanks for your attention. Hopefully hear from you if you have any questions.